Welcome back. This is our Algebra 2 quadratic functions lesson number 7, quadratic inequalities in one variable home review part 2. Please make sure you catch part 1 because we go over a technique called sign analysis that will help us solve these problems algebraically. Okay? Question number 4. The solution to the inequality x squared minus 9 is less than 0 can be expressed graphically as. So a couple of things we can do. First off, we take a look at our symbol here, less than 0. Now, less than 0 is less than 0, but not equal to 0. So in this case, very important, not equal. Now, if we were to factor this, we would find in this case we'd have x minus 3, x plus 3 times x minus 3 is less than 0. Okay? And that would mean in this case we'd have x plus 3 equals 0, x minus 3 equals 0, and so at the roots, x would equal to negative 3, and x equals to 3. But we don't have equal to, so at any time this is equal to or a closed dot, we cannot have that. So here we have, for choice 1, we have a closed dot here at negative 3 and positive 3. So that means they include those values, but in our equality it's not. So it cannot be this one, nor can it be this one. Because again, they include negative 3 and positive 3. We're looking for values that do not include negative 3 and positive 3. Now, we can do a sign analysis, or we can just plug a number in. Now, what number can we choose? In this case, because the two choices here between 2 and 3, they look like they're either less than negative 3 or greater than negative 3, because that's what this looks like. It means x is less than negative 3 or x is greater than 3. Well, this one's going to be x is going to be greater than negative 3, and at the same time, x is going to be less than 3. Now, by the way, this also written as negative 3 less than x is less than 3. Now, interval notation, because we talked a little about 4 yesterday, in the last video. In the last video, we saw that in this case, interval notation would be open bracket negative 3, comma 3, meaning the endpoints of this solution would be negative 3, but not including, and all the values being positive 3, but not including 3. The open bracket means we don't include, almost like an open circle. Now, for choice 2, your interval notation would look like the following. Definitely negative 3 at the right endpoint, but not including open parenthesis. And then negative infinity means, in this case, that we're including all the values of x less than negative 3. Okay? Or it can be written as an upside down u or an upside down v in this case. This is a disjunction. And so here, 3 comma positive infinity, meaning our lowest value will be up to 3 but not including 3, and the highest value in the interval, or in this case the range of values in this parenthesis here, will be up to positive infinity. So now how do we see which one works out? Well, we can do in this case, we can probably pick a value like 0. Does 0 work out? So let's take a look. So here we go. 0 squared minus 9, is that less than 0? Well, negative 9 is less than 0, and so that works out. And the only one that has a choice with that, where in this case 0 is shaded, is choice 3. And so that's one way to do this as well too, in case you had to figure out values. Number 5. Which of the following solution set for x plus 5 times x minus 3 is less than 0? Okay, so here we have this already factored, and I'm going to set each of these factors equal to 0 to find our important values. Now use sign analysis in this situation. So here we have subtracting 5 on both sides. X equals negative 5 is an important value. Add 3 to both sides. X equals 3 is an important value. We create a number line where negative 5 and 3 are the important values here. And we'll see we have 3 regions. So in region 1, I'm going to find a value of x that's less than -5, in this case, -6, and then plug into the factored expression here, x plus 5 times x minus 3. So we're going to have, in this case, plug in x with -6, -6 times, sorry, -6 plus 5. Sorry about that, ladies and gentlemen. Just want to erase this here. Made an error, which happens sometimes. So -6 plus 5, and then for the second parenthesis, I'm plugging -6 for x, so -6 minus 3. And we'll see in this case we get a negative number times a negative number gives me a positive result. Therefore, in region 1, I have a positive result. I'll label region 1, region 2, and region 3. Okay? All right. Now for our second region, for value between -5 and 3, and let x equal to 0. Again, I like 0 because it's a nice number to use. And so we have here, plugging in here, for x 0, so 0 plus 5 times 0 minus 3. And so 0 plus 5 is a positive number, it's positive 5. 0 minus 3 is a negative number, -3. But I would just care about the sign value, so positive times negative is a negative value. And so in region 2, any value of x you pick between -5 and 3 will give you a negative result. Okay? Finally, region 3. In region 3, let's pick a value greater than 3. Let's let x equal to 4. Push down a little bit here. Okay. And so we plug in, and we're going to get the following. 4 plus 5 times 4 minus 3, which means in this case we're going to get a positive value times a positive value equals a positive value. So if you pick any value of x greater than 3 for this expression, you will get a positive result. So now, in this case, we want our result to be less than 0. And less than 0, that's negative. Okay? So we're going to have an open circle at -5 because it's not equal to a circle at 3, and the only place we have negative results for values of x's, those values of x's would have to be between -5 and 3. And so here, all values of x between -5 and 3, here we have -5 is less than, but not equal to, x is less than 3. And here, that would be choice 1. Number 6. Which inequality below represents all solutions for x squared is greater than or equal to 5x plus 24? Well, we're going to use sign analysis in this case, and so first what we do is we want to move everything over to one side, setting the inequality equal to 0. So we're going to subtract 5x and 24 on both sides. So we get x squared minus 5x minus 24 is greater than or equal to 0. So now we're going to factor, and we factor here, x and x, two numbers that multiply 24 and subtract to 5 are 8 and 3. The large number gets negative, the opposite is positive, so we can definitely see -8 plus 3 gives -5 in the middle, -8 times 3 gives -24. And this is going to be less than or equal to 0. Now this time around, we are going to equal to those values, so whatever we have is going to have the equal sign. So, all right, and we set each of these factors equal to 0. We have x minus 8 equals 0 and x plus 3 equals 0. And we get, in this case, x is equal to 8, subtracting 3 on both sides here, x equals -3. So now we have our number line here, and I don't need to make it that big here, but here's -3, and here is +8, okay? And so we have, again, 3 sections we're going to test with our sign analysis. And here's region 1, region 2, region 3. Our first test will let, in region 1, let x equal to a number less than -3. I'm going to -5. Okay? and we plug in this case, -5 for the factor expression. Our factor expression is going to be x minus 8 times x plus 3. This is an equivalent inequality to x squared is greater than or equal to 5x plus 24. So whatever works for this inequality, the x minus 8 times x plus 3 is greater than or equal to 0, will work out for x squared is greater than or equal to 5x plus 24. So we're going to now plug in -5 for x. So we have -5 minus 8 times -5 plus 3. Now -5 plus minus, -5 minus 8 is a negative value, and -5 plus 3 is a negative value. That gives us a positive result. So if you pick any value for x less than -3, you're going to get a positive value for your inequality. Okay? Region 2. That's between -3 and 8, and for those situations, I like letting my x equal to 0, because 0 is a nice number to work with. Pretty easy to calculate. So we're plugging in 0 for x, so we have 0 minus 8 times 0 plus 3. That's equal to a negative number times a positive number. That's equal to a negative result. And so that means in this case, if you pick a number between -3 and 8 for x, you can get a negative result. And then finally, for region 3, I want a value of x greater than 8. So let x equal to 10. And so for x equals 10, plug in here, 10 minus 8, and then 10 plus 3. Now 10 minus 8 is equal to positive 2, so it's a positive number. 10 plus 3 is definitely positive 13, so positive. When we multiply positive positive, you're going to have a positive result here. So we've completed our sign analysis, okay? And now we want to read the very important information here. We want to see when our values are going to be greater than or equal to 0. Now I know you're probably saying, but that doesn't say that in the original inequality. But what we did was we found an equivalent inequality that allows us to figure out what our solution should be. And our solutions say in this case that we are looking for values of x definitely equal to -3 and definitely equal to 8, because of the equal sign. But positive results, because we're looking for numbers greater than 0, that would mean when x is going to be less than -3 as well. Also, we see a positive result. I'll use purple for this one. When x is greater than 8. So we see here in our graph, we have x is less than or equal to -3, or x is greater than equal to 8. And we see that's going to be true for choice 4. Okay, everyone? All right, ladies and gentlemen, this is the end of our Algebra 2 quadratic functions lesson number 7, quadratic inequalities of one variable, home review, part 2. Again, please, if you like this video, if it found you helpful, please give a like, appreciate that. And if you still have any questions or comments, leave in the comment section below. And if you have not subscribed to the channel yet, please do so, and turn notifications to be alerted when new videos are added. All right, everybody, look forward to seeing you in our last video, part 3. Okay, take care, be safe.